Hello students, welcome to Math 1100 College Algebra. Lesson 0 is an optional lesson that covers only the preliminaries. Therefore, a lot of students just skip it, and that's okay. If you have strong enough background in prerequisite materials, you can skip entire lesson 0 or any part of it. Otherwise, let's begin. Section 1, Sets and Numbers. Everybody should know what a set is, what an element and subset is already, but here is a brief reminder. Here is a list notation of a set, 3, 6, 9, 12, and so on. I think the pattern is explicit enough, but you can be even more explicit like this using the set builder notation. Set of all x, where x is a natural number that is divisible by 3. Let's consider a couple of examples, element and subset example. And these two correspond to element versus no element. And these two correspond to subset or no subset. We use this notation which came from E for elements, and this notation here which was derived from the element notation E by removing this middle bar, and this represents a subset. Let's go back to the first example here. 27 is a multiple of 3, so it belongs to the set S, while 34 is not. Now, how about this example here? Both 3 and 30 are divisible by 3, so they are both members of S. So this set consists of the members of set S, so it's a subset of S. The final example here is not a subset because 2 is not divisible by 3, so this 2 does not belong to S. Consequently, this set is not a subset. Here's another reminder. I'm going to use these kind of abbreviations a lot. I'm going to use double struct fonts N, W, Z, Q, R, and C for the sets of natural numbers, whole numbers, integers, rational numbers, real numbers, and complex numbers, respectively. The default here is R, the set of real numbers. If I say nothing, it's coming from the set of real numbers. Here are some more examples. Intervals. The first line is a closed interval. Set of all real numbers between a and b, where a and b, the endpoints, are included. You see the less than or equal to notations here, so equality is included. The second line is an open interval. Set of all real numbers between a and b, strictly in between a and b, so that the endpoints a and b are not included. Third and fourth lines are half open, half closed intervals. Now, the default is R, so if you remove all these, that's not going to change anything. So even if I do not explicitly write x belongs to real numbers such that, you can still consider it's coming from the set of real numbers. So there's nothing there. That means, oh, it's a real number. That part is hidden. So that's the default. Sometimes, of course, when things are a little bit more explicit, then I'm going to use some other set if there's no danger of confusion. Things like this. For example, x is a natural number that is divisible by 3. Yeah, I can abbreviate like this. S is set of x where x is divisible by 3, and that's going to be still okay. I mean, it's not really perfect because you see here, there's no negatives here. So if I simply say divisible by 3, then negative multiple of 3 should be also included. So there's a bit of an ambiguity here, and that's always the case when you skip something here. But if you put something explicitly, like this, then all is complete. If there's nothing here, then that means it's coming from something that's not that important. Some confusion may exist, but it's not that important. Like this example I just showed you. Or it's coming from a real number. Most of the time, it's going to be the latter in this course. If I say nothing, it's coming from the real number system. By the way, here are some visualizations of these. Closed interval, everything in between, including the point A and point B. We have solid dots, so those are both part of the highlighting. Here's a visualization of an open interval. This time we have hollow dots. So A and B are just placeholders here. Themselves are not part of the highlighting. It's white. And then half open, half closed intervals. So semi-equality part, included part is solid, not included part is hollowed out. That's for blue interval, but vice versa for green interval. Okay, so much for the intervals and set notations and so on. The next topic is algebra of sets. You can add two sets, kind of like this, which is called a union. So element of A or element of B, everything put together. So if you take union, basically we are adding up all those possible elements together. Logically, it corresponds to A or B. Here's a concrete example that appears in college algebra. Consider these two intervals, blue intervals and red interval, and then we join them together as a union. So what do we have? Belongs to blue interval, which means x is less than 2, or belongs to red interval, greater than or equal to 5. Graphically, it goes like this. Blue or red. Either way, it's okay. So union will make the set larger, and here's the other way around, intersection, which will make the set smaller. A and B, logically, intersection corresponds to and. So it must be part of A and also part of B, so only this part, the intersection part. Here's a concrete example that appears in algebra exercises. This blue interval and red interval put together. So we have to find numbers that belongs to blue and red together. So less than or equal to 5 and greater than 2, which means greater than 2 but less than or equal to 5, this middle part. That's the intersection. Okay, hard part is over. This is negation, all except A, so we just go outside. And here is a concrete example. All real numbers except -2. This one is expunged out, outside all these. So this part or that part like this. And we can join them together using the union for the first left-hand side part and the second right-hand side part together. Finally, the set minus. A but not B, that crescent region, or B but not A. Here's a concrete example. Belongs to this interval -1 to infinity, but not in this set. So basically I'm expunging x equals to 2 out, and here's a visualization. That's out. So from here to there, but expunge this one out. And also this can be rewritten as a union of two intervals like this. The left hand side here, union the right hand side like that. In general, we can express all kind of one-dimensional sets in real number system as intervals like these. We're going to do these a lot in this course.